Hello everyone, this is just another battery management system update. So I've made some changes. As you can see, they are now installed on my big main battery bank because we're in the testing phase now. I had a comment saying that the LEDs were too bright, and I agree with this. Even still, with 2 kilo ohm resistors on the LEDs are still a little bit too bright. So I'm just going to up the resistor values until these LEDs aren't so bright to look at. Like I can maybe have the under voltage and over voltage warning LEDs very bright, so they're very easy to see. And the power LED I think can do with being a bit dimmer. So in regards to balancing, I'm having a bit of trouble with them. I can't seem to get the pack balanced to within the millivolt that I'm going for. And I think this is because I've designed them such that the range of voltage which you can set these to balance over is just too much. It's 3.8 something to 4.2. So that means that when you turn this adjustment, it's very easy to overcompensate. So even just a small turn on that might equal quite a few millivolts, so it makes them quite hard to adjust. So I'm going to revise the design again so that you can only select between 4.2 and maybe 3.99 volts, something like that, and that will make them much easier to calibrate, because I think that's the reason why I cannot get this pack properly balanced. It's just because when I see a cell that's too high or too low, I go and turn that, and it turns out that I overcompensate it, and then it just goes out of balance in the other direction. Although it's strange though, because on this pack with the smaller cells, I was always able to get it to balance to within a millivolt. But I think there may be another problem where over time these are drifting out of balance. So even though I set them at a voltage and leave it, it's like it's drifting over time. Maybe not, I'm not sure yet. So that's why I'm going to be testing these for several months before I even decide to sell them to anyone. Because I do not want to sell someone crap. So they're all going up to the central control unit here, which basically just handles the over voltage and under voltage signals. I'm thinking about changing the design as well, because I think I mentioned in a previous video that this balancing LED comes on a millivolt before the units themselves start balancing. And I'm going to just remove that so it's not misleading at all, so that whenever this LEDs is on, you know that the units are definitely dissipating power into resistors and balancing. Most Chinese battery management systems, and I think a lot of battery management systems in general, actually use MOSFETs for switching on the load in the charger. But I do not really want to do this. The reason I'm using LED relays is because if the user messes up something and puts the wrong voltage through it, or connects it up the wrong way, it could send too much voltage back through the MOSFET when it shorts out, and then it could destroy all of the battery management modules as well as this main control board. So the way I had this connected up is I had 12 volts going through the charger relay, and that went up to a contactor attached to the solar panels, so that if there was ever to be an over voltage warning, it would just cut this contactor off until the user comes and checks out the problem and resets it. And that worked really effectively. But the issue was that these contactors, these big ones, consume 5 watts. So I'll release another product, probably a PV voltage trigger device, so that whenever the voltage is over a certain value in the morning, say like 20 volts or whatever voltage a customer chooses, it'll just switch on a relay and allow this contactor to come on, provided there's not an over voltage warning in effect, and that'll just save extra power. So other than that, they seem to be performing quite well. They will take a long time to balance an enormous pack like this. This is over 400 amp hours here. I think it's something like 420, I think. And these only balance at 1 amp. But that's not a problem if you've got a nice high quality pack and all the cells are the same, like in this case. The only reason it's getting knocked out of balance is because I'm testing these, adjusting them, accidentally overcompensating, and it's just knocking everything out of balance a little bit. But before I put these on, this pack was staying balanced to within a millivolt. I would only go out of balance by about a millivolt or two per month without any active balancing. I was just shorting a resistor, a low value resistor, across any that were going out of balance and just balancing it manually. But that's obviously a lot of hassle. So that's what I'll do. I'll revise the design again, and then hopefully with the adjustment being much finer, it should be easier to set up. Because the way to calibrate these is, it's probably not a good idea to do it while they're on the battery themselves. It's probably good to well, I'll obviously do this before I send them out to customers. I'll calibrate them to a certain voltage myself, and that'll be done using a high precision power supply, and then these will be adjusted on the high precision power supply before being put on the battery. But if the customer wanted to change the voltage, ideally they would take these off the cell and connect it up to a precision power supply and then adjust them that way. But maybe not. You could probably adjust these on the cells if it's a small pack like this, because it's only an amp on a 40 amp hour cell, the voltage would change much quicker and you'd be able to calibrate them. So it shouldn't be much of a problem in that regard.